Okay, welcome. Welcome to the Optics and Optical Engineering Academic Open House presentation. We're glad to have you with us, and we're looking forward to giving you some experience on the early stage of what optics and optical engineering are all about at the University of Rochester. Thank you for coming by. I'm gonna give myself a nice pointer, and we're off to the races. Okay, the first thing I want to do is let my other panelists say hello. I will call out individuals' names so you don't have to guess which one of you there is. So I will start by letting our student panelists who are current undergraduates in our major say hello. I'll start with Benjamin.
Hey everyone, my name is Benjamin. I'll be a senior in the optics department starting in the fall. And it's great to have you all here. Looking forward to telling you about the optics department.
Great, thanks. Margaret, next.
Hi everyone, I'm Margaret. I'm going to be a junior in the fall studying optics, and I'm looking forward to chatting with all of you.
And Christopher.
Hi, I'm Chris. I'm a rising senior, like Benjamin, and I'm majoring in optical engineering. It's good to be here. I hope we can be helpful to you guys.
Okay, and we also have some fellow faculty of mine in on this call. Julie, can you say hello? I'll let Scott jump in if he's there.
Oh,
Julie,
all
you're
right.
muted.
I got it.
Go ahead, Julie.
I made the sin. Hi, my name is Julie Bentley. I'm a professor at the Institute of Optics, and I teach classes in optical design and geometrical optics.
Great, thanks. And Scott.
Great. So first of all, howdy, Blaine. Thanks for chiming in on the chat. You can go ahead and use the chat or the Q&A. I think the chat is likely to get more attention. My name is Scott Carney. I'm the director of the Institute of Optics. I'm incredibly pleased to be here. The Institute has been doing really well with our undergraduate program, and I look forward to seeing you all in the fall.
Wonderful. And Tom Brown, you'll have to just join audio, but if you could just say hello just to complete the circuit.
Yeah, I'm Tom Brown. I'm also on the faculty here at the Institute. I teach the first year undergraduate Optics 101 Introduction to Optics. So I'm hoping everybody connected will be looking at signing up for that course, and we'll see you one way or the other come fall. And you'll hear more about some ongoing meetings from some of our undergraduate participants as we go on today, because this isn't the only opportunity you'll have to learn more about optics.
Absolutely right. Okay, and I'm Andrew Berger. I'm also a professor here in the department, and I'm one of the chairs of our undergraduate committee, and I get the job of just taking you through a little bit of an introduction about our department and our program. So let me first of all let you understand what we're in for here today. We've just done this first bullet point, and as was mentioned, there are multiple ways for you to send us questions during this talk, this part. You can raise your hand. You can enter something into the Q&A. You're probably most familiar with the chat function, and we have lots of us on our end monitoring the chat. So Q&A or chat, whichever you like. Q&A allows people to vote and say, I like that question, but I think chat's fine too. We will get lots of chances to talk with you. I want to let you know about other things. This is, as Tom Brown said, this is just the beginning. After this webinar, which is going to be archived, and you can see all this information later once it's uploaded, we have another Zoom that we have set up for immediately after this event, or even before this one ends. The student panelists are going to go there first, and that's going to be a chance for you to talk with them more actively. You'll be able to show your faces, you'll be able to talk. I set up 4 breakout rooms in this Zoom that you're seeing here. So this is something that I've asked to be put into the chat. If you aren't already seeing it, remind us. We'll keep putting it in the chat occasionally so you can copy paste that somewhere where you can then click on it later. So I want you to know about that. So this is a 2-part thing today. After this formal presentation, there will be the chance to just sort of talk with us, which is the more fun part. We're also going to have a bunch of getting to know about optics events throughout the summer. You're welcome to drop in on one or many because they're going to be different. We're going to have little demos for you. We're going to have chances to let you learn a little bit about what our field is. They're going to be on many Tuesdays throughout the summer. I have listed here some of the dates that they're available, that they're currently planned for. The first one's coming up next week on Tuesday at 4 o'clock. And I believe that the Zoom link for that is also going to get put into the chat. You can also check our website of our department, and that will also soon, not at this instant, but we're going to have that information available for you. Okay, so, all right, now for about optics. So optics is the study of light. And we're excited that you all came here for whatever reasons to learn about it. We do all sorts of things with optics. I'm not going to go hard into this, but we definitely want you to understand that optics is a field that involves a lot of what we would call a traditional science discipline, where you ask basic fundamental questions. How do these things work? Why is this happening? And we also do a lot of engineering in optics, as you can see in the words here. We'll have some more slides to bolster that up. But that optics spans a whole range of things, and you really can think of it as something of a marriage of physics and electrical engineering. If you wanted to relate it to the two most close fields you've heard of before, optics shares a lot of components of both physics and electrical engineering. You may have heard the term photonics, and photonics, we usually in the department think that photonics is optics. They're really not radically different terms, but if you've been experiencing the word photonics, you probably have heard it not so much referring to lenses, more often referring to things where the word electronics might come up in the same conversation. But for today, ask us questions about this down the road, but optics and photonics are fairly interchangeably used terms within the professional community. And what do we do? Well, there's a whole list, and since you're going to be able to look at this in the future when this is archived, I don't want to spend a lot of time on this. The list itself is not super important to memorize, but I've highlighted a couple of words here. So you all know there are a lot of space telescopes out there. There are more that are being launched, and certainly space telescopes and imaging satellites, Google Earth that you look at all the time, you need optics for that. I've got a slide here from the people in the Center for Visual Science. Some of our most exciting work in optics that the U of R has done on the eye. This is an image of a retina. The larger, darker circle regions that you see are places where there are cone cells, and in between them you see little rod cells that are even smaller. University of Rochester was the first place where people were able to take images with this resolution, at single cell resolution, inside of a living eye. We'd be happy to tell you a lot more about that. It's a big, big thing here. Single photons are used to send unbreakable cryptographic codes. That's something we'd love to tell you more about. And you probably have also heard the term quantum computing. That's something that is deeply involved in many optical manifestations. Another thing, a very different sort of thing, virtual reality, augmented reality. This is both for gaming, which is a big driver of the technology, and also lots of practical applications, surgery, for instance, being one of them, where you can augment what the surgeon is looking at as they're doing surgery. We have people in our department. This is a slide from the website of Jeannick Roland, one of our senior faculty members who works in this area. Photonic chips, the things that are typically done on with electronics on computer chips are increasingly moving towards doing a lot of these and other sorts of tasks using light instead of electrons for as many things as possible. It's faster and has a lot of other advantages. Happy to talk to you more about that. I happen to work in the area of monitoring human health using light. One thing you may have had, if you've had surgery, you may have had something clipped onto your finger that shines light through your finger to measure your blood oxygenation. That's just the tip of the iceberg. You can think about microscopy as another area where people do a lot of health-related work using optics. Solar energy. Increasingly, you folks are graduating into a world where you know that we have to move towards more sustainability in our energy. One of the biggest environmental things that optics is involved in the effort to more efficiently capture and harvest solar energy, both in how we steer it towards detectors and the kind of materials in those detectors that collect the energy. Of course, telecommunications, optical fibers, sending information at blazing speeds, ever faster, ever more densely through optical fibers, that's a big optics thing as well, both the materials in the optical fibers and the light signals that are sent through them. We do a lot with lasers. Everyone in optics does, but we have a big laser lab at the University of Rochester, so we are particularly focused on lasers and building better lasers, and that could be faster, it could be cheaper, it could be lighter, it could be a wavelength that isn't currently easily able to be made. We do all sorts of things with lasers in the optical field. And as I said, we have a laser lab here at the U of R, and that's where attempts at doing nuclear energy fusion is something that's explored there. And we also study the physics of very high intensity events that are like star formation that can be explored with the powerful lasers that we have there. Of course, no list of what we do with optics would be complete without talking about all of the lenses that are involved in this. And so we go all the way from designing them, as Professor Bentley mentioned, as to manufacturing them, to making them ready for prime time by polishing them, and then we test them. So lenses, of course, are a huge component. We often like to tell people, look, just look at your smartphone. I'm not even going to enumerate it, but while you're sitting there thinking about it, think of all the elements in your smartphone that are optical in some way, shape, or form. And of course, it's enabling this video conference. Think of all the things that I'm doing right now, going from me speaking and my video being taken to you being able to see this presentation. And Professor Brown was kind enough to share with me an optics mind map that he made recently. And this just sort of gives you the global sense that these I'll only look at the major terms here: energy, laser design, photonics, quantum optics, optical fabrication, virtual reality, optical design, biomedical optics. There's a whole lot going on out there. There's something in this field for everybody. And as I'm going to tell you soon, there's enough in this field for everybody to get a job. There's that big fish swimming around in a small pond. If you're curious about what it's like to be an optics major in terms of what these people end up doing next, I don't know if this 50-50 split is accurate. It jumps from year to year, but our graduates from the BS program, they get jobs at companies, they walk right into them, and they also go on to get graduate degrees. Some of them, of course, take a job for a while and then go get a graduate degree. And of course, the ones that get graduate degrees often go off and work somewhere. So our experience that I can tell you straight out is that anyone who keeps their focus on the prize and goes through our major, you do not have to be an A++ student. If you get a degree from the Institute of Optics and you take advantage of the opportunities that are within the field, you will find something that you want to do when you graduate, whether it's narrowly within optics or something that more broadly connected to it. It is pretty much a great guarantee that very few departments can make as confidently as we can. And one of the reasons for that is that we have a program called the Industrial Associates Program. And so I want to just take you on a flyover of a couple of special things about our department. And the first one is this: companies are interested in paying into a program where they get to come to campus for a couple of days and catch up with us and interview the students. And so we have these bazaars that are there where students get to mingle and talk with the representatives of various companies. The companies are very eager to explain what they do because they want to hire these people. And the students, of course, are very eager to make connections. Sometimes students talk to these companies, every semester for all 8 semesters of their being here at Rochester, and frequently it leads to summer internships, or it can eventually, when they graduate, several of these people, it leads to jobs. And that's a really nice aspect of being in a department that's known without the optics world as being, throughout the optics world as being a gateway to talent. You can recognize some of the titles of these companies that are out there. A lot of stuff in Silicon Valley is currently very interested in us, not just this company, but Facebook and a lot of the computer chip manufacturers like Intel. There's a whole bunch of things in there. We're happy to talk with you more about that. Next, a little bit about the Institute of Optics. So it may be confusing to you. We are the optics department, just like the mechanical engineering department, but our formal title is the Institute of Optics, and that goes back to a history starting in 1929, when we were founded. So we are the oldest institute that teaches optics to students in the USA, and that's no accident that we are in the city where Kodak and also almost as well-known company Bausch & Lomb are located. So We've been teaching optics for a long time. Our building, if you haven't seen it, haven't the chance to see it yet because of the COVID situation, this is us lit up at night. This is the Wilmot building where we started out, and a couple of, about, what is it now, about 13 or so years ago, we opened up the Gergen building, which we share with people who do biomedical engineering. And this is what the interior of our building looks like. It's a wonderful place. It's a friendly place. On sort of the upper levels, off the screen here, are the floors where the optics department has lounges, and a lot of the students can attest that this is a place where a lot of bonding takes place. I'll say a little bit, again, this is partly for archival purposes for people who don't have the chance to join the Zoom that you here will be able to join later. But our curriculum, I just want to let you understand the basic ideas of it. The contours of doing an optics or optical engineering degree are that in your first year especially, there's a lot of common things in physics, math, and other areas that you need to start getting good at. The formal required curriculum starts usually in the sophomore year. I have a second slide to talk a little bit about that detail in a minute. And we have a bunch of laboratory classes. They're just numbered 201 through 204. They introduce you to experiments that help you explain all the various natures of light. We think about it sometimes as arrows, like a laser beam. Sometimes we think more about the wave properties of it, like ripples in a pond. And we also sometimes think about it quantized, where we talk about photons. We have a bunch of core classes that you can read the titles of here. We start you off giving you the basic ideas of having a lens and an object and thinking about forming an image of it and what the magnification is and all those sorts of rules. Some of you may have covered a little bit of optics in your high school. Most of you probably not very much or any at all. We assume no prior knowledge in optics in our program, and so we start you right off with that beginning stuff. And we walk you all the way through how light spreads out in space, how light diffracts, how it interferes. We talk about the way that lenses, just because you throw some lenses at a problem and form an image, that's not a perfect image. And we talk about making the right choices of lenses in those situations and what the limits are and how good the images are. We have a class on light sources, light detectors, light waveguides, and we still keep giving you lots more methodologies within math, and we have a class on quantum. So there's a whole range of things that an optics major learns how to do. You also have your chance during our program to take elective classes that in STEM disciplines. Some students choose to take all three of those classes in optics. Some students choose to take all three of those classes in other departments such as math and physics, computer programming, to name some popular examples. And then everyone who graduates from our program does some sort of capstone experience. Either you work on a design team or you do an independent project of some sort. And we can talk to you much more about that. But this just gives you the thumbnail sketch of what's going on as you rise through our optics program over the course of 4 years. Many people are probably curious about what would you do this very coming fall if you are interested in pursuing optics. And here's the answer. There are 2 classes that are offered in the fall that are not uncommon for an entering first semester student to take. The less common one is to start off in geometrical optics. And that's typically a sophomore class, but if you are coming in with enough AP credits, there's the possibility, and we will discuss that with you, it's not something to spend time on now, that you could start off in our geometrical optics track. This would be not unlike coming in to the physics major and saying, look, I've already taken APs in mechanics and electricity and magnetism. Can I start on some higher classes? This is a conversation that you have with your academic advisor and eventually with the faculty of a department. We're no different. So you might start off doing geometrical optics. Most people who haven't had much experience to optics before and who are wanting to see about this whole optics thing before plunging in, the more common thing is to take the Introduction to Optics class. That's called Optics 101, and I'll show you a little slide about that in a minute. So most students in our major take one of these 2 classes during their first semester. So that's their chance to do some optics right away. Typically, you'll take a semester either of chemistry or physics, depends on your situation. That would be a second class that you would be taking. almost without exception, every student would take a math class. We have a calculus sequence here. If you've taken an enormous amount of calculus already, you might take differential equations and linear algebra right away. Those are the two likely things that you would do. And the fourth class that typically you take in your first year is either a writing class. Everyone's required to do a writing class during that first year, or you take a cluster class, something to diversify yourself. We don't want you spending all your time doing all this science-y stuff. We want you to have something else to vary your pace. So this is the typical semester for you. We will talk much more with you if you wish about the nuances of this, but the first semester typically looks something like this. You're only allowed to take 4 full classes, and they'll usually fall into these 4 buckets. But of course, there are always exceptions. Maybe you'll be one. I mentioned Optics 101, and I just want to let you understand that Optics 101 is an overview of the field of optics. It's taught in a very accessible way. It doesn't assume a whole lot of mathematics, as you'd have to understand. And at the end of the semester, we put people get put into teams. And I'm just showing one screenshot of 4 students who were making a presentation. And so we have a poster session like this. They get a couple of sessions in a laboratory. They get a little more of a chance to see, firsthand what taking data is all about, what it's like to be inside of a laboratory. Here I am coughing in the background, apparently. So just want to let you know that the Optics 101 experience, it's a real bonding experience. Many people, when we ask them when they graduate, what do you remember a lot about going through this program? If they were in 101, almost unanimously, people say, oh, that was such a great introduction. It really got me hooked. I came to the U of R knowing nothing about this field, and here we are. So I really encourage people to visit Optics 101. Even if you come to U of R and don't take this class for any logistical reason, sit in on a couple of early meetings of it. First of all, you'll probably be tempted to take it after all, but even if you're not, it's really helpful to see an overview of the field and just get a sense of, hey, what is this optics thing? Most people, unlike electrical engineering and physics, don't really have much of a sense of what it's like to study optics as an intellectual discipline. This is your chance to find out about that. In addition to the industrial associates coming in and interviewing our students, that's one of many ways that students get a lot of opportunities to do research. And we really want to make you know that there are lots of ways you can do that. I'll let the students talk with you more about their own experiences that they've had when the time is right. But we have a lot of faculty on campus, of course, who bring students into their own labs, especially during the summer, not just within the Institute of Optics proper, but also the people who work on the eye, as I showed you that picture of. People at the laser lab take a lot of people over the summer. And there are other places at the medical center and across the river campus that are interested in our students. Any lab that has a microscope is a lab that might be interested in having an optics student help them learn how to use it. We are very well connected to local industry, as I mentioned, not just through the Industrial Associates program, but just in general. And there are many companies in the Rochester area and in the outside of the Rochester area that take our students for summer internships. And that extends also into sort of more national classified sort of stuff, aerospace and defense. There are national laboratories at which our students are very successful at getting summer internships. And increasingly, there are companies overseas that are interested in hiring our students. As our student body has become more international, so too has the interest in optics, Institute of Optics students. So it goes both ways. And I see the chat is pretty active, so I hope you're getting lots of feedback about things that I'm not saying. But our students are remarkably successful, not just at getting jobs after they graduate, if that's what they want, but also at getting summer opportunities. And the faculty are very connected to some of these places that can make those introductions for you. You don't have to do all the lifting yourself. A couple other things just about what we do in this department that you might not think about. We have a very active outreach program that the undergraduates drive a lot, along with the graduate students and the faculty. There is a student undergraduate chapter of the Optical Society of America, one of our major professional societies. You can see some of our folks here staffing a booth. And whoops, I thought there was a picture also of Christopher with a big lens in front of him, but I left that one out apparently. Sorry about that. But anyway, all right, too bad. Anyway, our students do all sorts of research doing cool demos. Optics is a fantastic discipline for hands-on and visual demonstrations just by its very nature. So we have crazy lenses, we have thermal imaging cameras. So it just sort of runs, we have optical fibers and light pipes, all sorts of stuff. And if you, at the end of this presentation, if there's time at the end, I have even some little demos I can show you folks. So outreach is a big part of what we do, and it's a great chance for you to turn into a teacher early on in your education. Optics is one of those fields that needs to be explained to almost everybody from kindergarten on up, and even earlier. So our students get a chance to do that. Very well connected within the community to do that. Another opportunity that undergraduates have to proselytize is a summer program called Photon Camp. If you want to put up in the chat, hey, I'm a former Photon camper, I hope there's a few of you out there who even were. So Photon Camp is something that we run for local high school students. There's a shot, I believe, from last year. Some of our students are listed here. Margaret, and you may be in there as well. I'm not seeing you instantaneously. But anyway, we bring high school students in, and they come and they spend a week. They get an experience in the laboratory. They get to do a final presentation. So it's a cool deal. And it's a chance for some of our undergraduates to interact with them and, again, teach them a little bit about optics, sharing what they know. So here's one of our recently graduated seniors. She's teaching a bunch of students, I believe. Well, she's holding a lens. I see this door over here is a huge camera obscura project. Have you ever heard of a camera obscura? It's a very old way of forming an image on a wall by sending light in through a pinhole. There's not even a lens involved. The image is upside down, if you've ever encountered that. We do holography with them. This is a hologram of George Eastman, the founder of Kodak. And an even lighter thing that has nothing to do with knowing much about optics is we participate in an annual grudge match with the physics department, a soccer match called the Photon Cup. So there's our last squad, not from this year. We weren't able to play it this year because, well, you can guess why not, because it's a spring event. But last year, this was our squad. We had it as a night game. We won, of course. We do not always win, but with you folks coming into the first year class, we're going to win next year for sure. And we even lift our students up in the air to cheer. So it's pretty cool. Everyone gets a T-shirt from a local, from a sponsoring company. It gets pretty official, and it's kind of fun. And it's just one, I put this up here mostly to show you that there's a lot of camaraderie in every department, and ours is no exception. The students who are in our program, really, they not only study together, they don't just work hard, they play hard together too. And we like providing these opportunities for them to really focus on their optics connections. Of course, they do things outside of the formal optics sphere as well. Okay, and with that, we are able to take questions. That is the end of that slideshow that I got. And now that I'm just going to flip forward one or two slides, and then I will quit the slideshow and turn us into a real Q&A section. So I think I'm not going to do the optics demo now, but if you want it later, you can say, hey, do that demo for me. And I just want to leave you on, this is the last slide. This is part of the archival stuff that we're supposed to create. And so I want to leave those of you who are watching this perhaps asynchronously with when I'm delivering it, a little bit of contact information. Normally, the main contact info I'd be providing to you is our department's undergraduate coordinator, but because we're cycling through various staff members having to take some leave this summer, he's not available until early August. So until that time, if you want to contact somebody, you can contact me. So I'm one of the chairs of the Optics Undergraduate Committee. You can see my email address there, and that's how you can reach me. Please feel free to get in touch. We also have two online places that you can look for information. One is our departmental homepage, which you've got listed there. Pretty easy to guess what that is, and you probably all have found it before anyway. And we do have a Facebook page as well, and I'll just leave it to you there that we have a Facebook page. So check that out. I don't know how actively that's being posted to this summer because our undergraduate coordinator is the one who often puts a lot of stuff on there. And as I said, Dustin is not available right now. So with that, you have some ideas of how to reach us. I'm done blabbing. I'm going to do what I need to do to escape from this presentation, which is sometimes easier said than done. And I'm going to stop sharing. Okay, so we're now out, and I am now going to try to flip this, which is to say that I'm going to try to let the students, Benjamin, Margaret, and Chris, have the opportunity to answer questions first, and I'm going to start looking a little bit more at the chat room and so on and so forth. So, but if one of you who has been monitoring the chats wants to name a first question and an opportunity to answer it, please go ahead. So one of the other panelists, if you can jump in and say, hey, I see a question and let me answer that, that would be great.
Andrew, are you still recording this part too, or?
Yes, we're going to continue to record this Q&A, and at some point, as we will send you off to the other Zoom link. That will not be recorded. At the moment, the reason why we're continuing to record this is that this may also be of value to people who only are able to watch this in the archival version. So if there are some questions of a general nature, that's a good thing to ask for now. And remember that you'll have a chance to talk with us more informally and one-on-one if need be through breakout rooms once we end this. But if you've got some general questions, or if they've come up during the chat, the things I'm thinking about, or if you want to ask our students, what's the program been like for you? Why should I be an optics major? That's a great question. And if you want to ask questions about, hey, I have some thought about, is this something I could study in optics? Like, would this count? Is this the kind of thing I could get good at? Is optics the right sort of major for that? That's a great question to ask. Getting into the weeds about what are you going to take first semester, other stuff like that, setting up internships, things about the future, please ask them, but that's stuff that I think we might say, let's talk about that one-on-one with you in the other room. So with that, I'm going to try to take it to myself out of the hot seat, and maybe someone can jump in with an answer to a first question. I can start now. I've got my hands under me. So this is a good one. Okay, so Jiva. There's a theater here called the Jiva. I don't know if your name is pronounced that way, Jiva Ozeri, but I will guess, and I know you can't tell me otherwise. So Jiva asks, how much time is available for incoming freshmen for other activities aside from classes? So I'm just going to start doing it randomly. Margaret, can you give us your answer to that?
Sure, yeah. So from my experience, optics students definitely study a lot, but we also are often a very energetic bunch and have plenty of time to engage in various activities within the optics department and outside of the optics department. I know a lot of people enjoy doing sports and different clubs on campus. I'm part of the Newman community and pretty active there. And then within the department, a lot of upperclassmen, sophomores and up are often TAing for the various classes. And so a lot of us are very involved in kind of getting to know students across the different grades and kind of community building. And so, yeah, I think we all have plenty of time to engage in the things that we love in addition to studying, which we also love.
Chris or Benjamin, you have further thoughts?
Yes. So I do a lot off campus as well. I play in multiple music ensembles. I play the trumpet and the guitar. I play intramural volleyball with a bunch of optics friends. A fun way to just de-stress for a little bit. I'm involved in a video game club. I'm involved in the Optical Society student chapter. We do optics outreach. And I work part-time, and I've TA'd a couple of classes now. So and I can speak for many people that are involved in activities from sports to music and anything in between.
Just to add on to that, especially as a first year, they do limit you to only a certain number of classes. They're not too tough. And you definitely have a lot of opportunity to go off and explore all the various different activities. My first semester and first year, I was part of the theater department. I helped set up and hang lights for them. I was part of the philosophy council. I'm still involved with that, actually, where we get together very casually every week and sort of just discuss some philosophical topic. This past year, and the coming year, I'm involved with the OSA student chapter, as with Chris, and with the philosophy council as well. And there's so many different activities and groups to get involved with. It's really just amazing. So you're gonna have a great time.
The only other question I've seen, okay, so I'll jump over to the Q&A thing, and I see one question that's still open, which is, are both optical engineering and optics majors that require only one cluster? That is a really on-target question, Amelia. The answer is that yes, the simple answer is yes. They are both majors, like almost all the other degrees in the Hagem school. You only have to do one cluster. You have to do a technical cluster, if you want to think of it that way, as your second cluster. But going outside of your technical discipline, one cluster. So 3 classes in a cluster plus 1 additional non-science class. There are details beyond that, but for these purposes, that's the answer. Great question. It's not obvious that optics would be included in that, but it is. Optics and optical engineering both meet that criterion. The other question that I'm seeing is questions about calculators. I guess it seems like there's been an answer to that, and I think, did any of the students have any comments about, I guess the question to put to the panelists is, do you find that there's big differences between what calculators, does it make a big difference exactly which calculator do you show up with? Is it important to show up with a graphing calculator? These kinds of questions. I'll just throw this one to Benjamin first.
I've been using the same GA84 since before high school, and it hasn't been an issue. Most things are done either on paper, just from class notes, or if you have to look up some crazy equation or plug something in, you can use Wolfram Alpha or some other website.
Yeah, I think one advantage that you students have is that the faculty did not themselves grow up using graphing calculators. So we tend, when you guys become instructors, you may ask questions and say, I expect that you will do this with a graphing calculator, but we're still in the era where most instructors are not asking people, we're not native on that platform. So yeah, I certainly don't assign questions where anything more than a simple calculator. I mean, you probably want something that can take trig functions, like don't just, I know my son and daughter who are in high school sometimes have to use just a 4-function calculator that doesn't even have trig, but I don't think any of you are going to come in with that. So it is a little subtle. Many of you may use a calculator that is on your smartphone. That is a subtlety to think about, because you can't use your smartphone during an in-class exam. So you do want to have some access to a calculator that is not a smartphone. So if that's something that if that's the way that you've navigated that, that's probably something that every 4 years, it's a different fraction of students that have any sort of calculator other than a smartphone. Although I guess you guys usually are ordered to buy a certain calculator for school in many school systems. So anyway, just take that one piece of advice, don't just bring a smartphone as your calculator to college. But you could, of course, buy one here as needs be. You don't have to have it be anything fancy. So I see, I know that there are only about 9 attendees out there. It's not that many people. So I'm going to make an executive decision here, which is to say, I think it's silly for us to be staying in this sterile environment where we can't see your faces. So let's do a check-in here. There is a post that was put up. Oh, okay, let me make sure the panelists can tell me. I'm seeing the one that was privately set up for the panelists. Is it in the? It's in the chat. Everyone can see the link to the after party. So I'm going to make sure that this goes off smoothly. So what I'm going to do is suggest that I can stick around here, but I would encourage everybody else to go to the after party now. I just don't see any advantage to staying here at this point. So by way of finality, before you all take off, thank you for coming. We're excited that you few proud managed to show up to hear us out. And we look forward to talking with you a little bit more now. And if you're watching this archivally, please check out our workshops that are coming up many Tuesdays, starting with next week on Tuesday at 4 o'clock. And there is information that you can get about that by looking at the Optics homepage. We'll get that posted as soon as we can, and that's optics.rochester.edu. With that, thank you all for coming, and I will dismiss everybody except myself to go head off to the after party. Thanks.